Okay, all right. Well, welcome everyone to our second Scalable Pandas meetup, and we're so excited that this is co-hosted with CoRise. I'm very interested to see how this plays out because I'm not accustomed to a Zoom setup where I have like a million screens. I took a lot of classes in grad school where professors like clearly were amazing at writing research papers, but so flustered by multiple screens. So we'll see if that's where I wind up today. So a little, just really quickly, I'm the chief of staff at Ponder, which is strange for me to say because I was a data scientist at Coursera until quite recently. So I sort of think of myself as a once and future data scientist. Yeah, again, we're so happy to be co-hosting this with CoRise. So I'll share my screen and we can dive in. Okay, let's do. This is that moment. Let's do share screen and okay, cool. Okay, so here's the agenda. So we'll very briefly talk about the purpose of this meetup. We'll do quick intros and then we'll dive into today's discussion between Sesh and Aditya. I want to remind everyone that this meeting is being recorded and it'll be posted to YouTube. But if you have objections to this, you can email me at peter@ponder.io. Okay, so just very briefly, Scalable Pandas meetup. This is our second meetup, and again, so happy to co-host with CoRise. The goal of these meetups is to discuss challenges people run into when using pandas with really large data frames and complex workflows, and then also solutions to those challenges. So we'll share stories, practical advice, examples, best practices, and we're eager to learn from all of you. And this meetup is kind of designed, I would say, on an emotional level for anyone who's ever like hit an out of memory error in pandas and been like, or you end up trying to parallelize pandas on your own, or it's like really slow because it's single core. If you ever have those frustrations, this is like the perfect place for you to be home. So Ponder is the enterprise-ready pandas company. We're the primary developer of the open source scalable pandas library Modin, which has actually just as of the past few days, has over 3.5 million downloads. And we're co-hosting today's meeting with CoRise. So CoRise, it's a new education platform that transforms the way professionals build technical high-demand skills through top industry instructors and through collective peer learning. The format of their courses is innovative. It mixes live instructor sessions with real-world projects and fireside chats with operators who are experts in their fields. Actually, so one of our speakers today, Sesh, is an instructor on CoRise, and he's teaching an Intro to SQL course that starts on, I think it's July 25th. So be sure to check that out. So why did Ponder start these meetups? We did it to build a community, content, and learning materials around best practices for working with pandas at scale. How often are these held? It's typically the fourth Thursday of every month. Today is not the fourth Thursday. So because of this opportunity to partner with CoRise, we're holding this session at a different time. Our next meeting will be in 3 weeks on Thursday, July 28th. And if you want to get involved, if you have any feedback or suggestions, or you'd like to present, you can email me at peter@ponder.io. Okay, so just some quick introductions in the chat. The set of things about you that we'd like everyone to share is your name, a favorite website, and personally, when people say like, "What's your favorite blank?" That is like a paralyzing question for me. So I'll say something in your top 10. You don't have to feel like you're insulting every other website you love. Something in your top 10, and then a favorite source of data news. So if everyone in the chat wants to share your name, favorite website, favorite source of data news, that would be awesome. I'll do the same. Aditya put ponder.io. That makes me feel like disloyal that I put a different one. Okay, Jason Dexter, Medium for all things analytics engineering. It's awesome. Sesh. Oh, interesting. I haven't heard of that website. Crickinfo, and then Google News. We have Sumit, Reddit.com, and Twitter.com. Yeah, Twitter is so good for data stuff. let's let a few more roll in, and then we'll move forward. Dybenko, YouTube and YouTube. Yes. Yeah, lots of great stuff on YouTube. Chess.com and Twitter. Definitely YouTube. Jason, I like the thought that your name, that the answer to all three is YouTube. Your name is YouTube, your favorite website's YouTube, and your favorite data set. Garish, Cricinfo, and Twitter. Am I saying that correctly? Cricinfo? I'll have to check that one out.
Yes, it's a site on cricket, which is followed by pretty much everybody in India. So
awesome. It's awesome.
Yeah.
Hugo, YouTube, Stackhouse, 3 blue, 1 brown. I went to the grocery store the other day and someone was wearing a 3 blue, 1 brown t-shirt in Salt Lake. And like instantly I felt so connected. Okay, cool. Well, we're so excited you're all here. And yeah, we hope you enjoy it and hope you learn. And we're excited to hear more contributions from everyone. So I get to introduce Sesh. So Sesh is a really interesting combination of academic and entrepreneur. So Sesh has his academic chops are really significant. IIT Bombay, Bell Labs database researcher. Sesh has founded several companies, a serial entrepreneur, which have been acquired, and so some really successful exits. And then Sesh has engineering experience at Google, leadership experience that's pretty extensive at Google and Target, AT&T, Lucid. So we're so excited to have you here today, Sesh.
Thank you.
And then we get to introduce Aditya. So Aditya is an associate professor at UC Berkeley, co-founder and president at Ponder. And Aditya's research focuses quite a bit on focusing on the human. So human-centered tools for scalable data science. Aditya has a PhD in computer science from Stanford, and Aditya has taught databases and SQL courses dozens of times. So both Sesh and Aditya are extremely qualified we have a lot to learn from them today, so I'm excited about that. Okay, great. So I'm going to actually stop sharing screen for the moment so we can focus on the participants. But now we'll dive into our Pandas v SQL discussion. So to get us started, one question I had this vision of like, what if someone finishes this meeting and at the end they're like, what is a data frame? Or like, what is a database? I feel like it's really important that we start just by making sure that we understand the foundation. So Aditya, if you wouldn't mind, would you mind getting us started by defining some terms? What is a database and how does it relate to SQL? And what is a data frame and how does it relate to Pandas? We'll start there.
Yeah, happy to start with a little bit of I guess context setting, definitions, and maybe a little bit of history along the way, because there's, I think, some facts that people may not know. So let's talk about databases first. So databases come from the data management community, and I think the most popular flavor of databases are what are known as relational databases, right? So and the relational databases support SQL, structured query language. Is a language that's been around since the 70s. And they store or represent data in the form of relations, which are basically unordered collection of rows or tuples, right? So that's the database notion. And so this came from the data management community, is incredibly popular, multi-billion-dollar industry, lots and lots of companies that support SQL as part of their database offering. In the early 2000s, there was this NoSQL movement, where there was a movement to move away from SQL in various ways. But everyone realized that at some point that was kind of a mistake, or at least the lessons that the NoSQL movement came up with were folded back into kind of relational or SQL-centric database. So that's your database viewpoint. So came from the data management community, originated in the 1970s, spearheaded by IBM and UC Berkeley. Those were the first two organizations that came up with the relational database. And then you have data frames. So folks may not everyone may be familiar with the fact that data frames also have an equally long history. So they date back to the 1970s, 1980s, came from the statistics community. So the statistics community had a language called S, which then became R. And so data frames was introduced as part of R, I believe in the 1980s, as a means to represent and reason about data for the purpose of statistical data analysis, right? So it was expressly developed for statistical data analysis. Pandas came about much later. So in 2008, I believe, was when Pandas drew on the lessons from R's data frames and then was ported over to Python. So what are data frames? So data frames are very similar to relations in that they are also tabular, right? They're a tabular collection of data, but they are ordered. So that makes them a little different. And they're also a little bit more flexible, right? So they support mixed types. They allow you to do more things with your data than what databases do, for better or for worse. And I bet we'll talk about some of those aspects today. But yeah, so Pandas is a language, is an API that uses the data frame abstraction. SQL is a language that uses the relational abstraction.
Thank you. That's great. And I hope people will forgive me. Probably today I will be a little loose sometimes in distinguishing between database and SQL and data frame and Pandas. There will be some moments where I conflate those, and purists will probably be unhappy about that. But Sesh, do you have any other comments about data? What is a database versus what's a data frame, or should we keep moving forward?
No, I think that was very well covered. Yeah, we can move forward. Yeah.
Great. That's great. So, okay. So before this meeting, I was talking to a friend of mine, a data scientist friend, who he was actually a little surprised by the setup for the meeting. Pandas versus SQL was confusing to him because he sees them as serving such different purposes that in his mind, like the versus idea was a really weird one. So I want to explore that for a second. So he sees relational databases as like efficient key value storage, but when you want to do deeper analysis, you materialize the view of the database as a data frame. You work within Pandas. So I'm curious, what are the axes along which Pandas and SQL, in which we could think about their differing? So like, what are the right axes for comparison? How could we structure this conversation? And yeah, Sesh, I'll turn to you for this one.
Sure, thanks. So yeah, no, I think the Pandas versus SQL panel, if you will, I guess, just was born out of some conversations that Aditya and I've had, in various contexts. And, Aditya has been working on making Pandas faster and optimizing Pandas and so on and so forth. And there are a lot of parallels to this having already happened in SQL. Purely, this is from a technology-centric view. But more centrally, I think the reason we thought it might be useful to contrast is this is often conflated as a either or choice. And we thought it would be good to sort of present the pros and cons of each one of these and the history and the origins so that people make the right choice for the right, shall we say, application. So that's the first reason why we thought this would be an interesting thing. And like you said, there are some interesting axes on which we can compare and contrast, and we'll get to that. I do want to say that, just a minor point. You kind of mentioned that databases are key value stores. Just want to point that out, that that's not necessarily, key value store is a subset of what databases can do. And that is, Aditya alluded to the NoSQL movement and why it failed. And actually, key value store was the centerpiece of NoSQL movement. So, and some of but having said that, there were some good things from there that got absorbed into databases, like Aditya said. So, just want to say, yeah, databases are, as Aditya said, general tabular, collection of rows, unordered, and that's what it is. And the rows need not be just key value stores. Having said that, how do we compare? I think here are some things, and there could be more, and people can jump in. One is, what are the typical personas that tend to use SQL or that tend to use, Pandas? And we can delve into that, but I think they are different. Typically, they're very different. As a result, the use cases and the applications are also very different. So they typically tend to get used very differently by these people for very different use cases. So I would say that's the second thing that is noticeably different. The third thing is, in general, both of these are fairly mature now and fairly, what shall I say, ubiquitous almost. I mean, by that, I mean, I think SQL and Python are arguably the most popular programming languages out there right now. I mean, in terms of the number of people, whatever metric you use to measure this. And what is stunning here, to me at least, is if you had asked me, I mean, I'm not that old. I was not around in the 70s doing research, but at least the grapevine I've heard in the 80s and late 80s when I started my database research is SQL was not necessarily the most elegant language, or it was not necessarily even fundamentally the best language in any sense of the word. And it just happened to win this whole intergalactic data speak. I mean, SQL is called the intergalactic data speak many times, and it kind of won that award or won that thing. But the fact is, it's 50 years old, almost 50 years old. I don't know of any other programming language that's that popular after 50 years. So that's an incredible statement to make. I mean, and clearly Python is taking over data science, and it's very clear. So anyway, the bottom line is they're very, very ubiquitous entities, and there is lots of what shall we call ecosystem and other paraphernalia that surrounds them, and so that would be another interesting axis. So personas, what are the use cases and applications? What is the ecosystem? And last but not the least, in the context of large data, how do these scale and perform? So I would say those are probably the four axes in which one could think of comparing and contrasting.
Okay, yeah, that's great. Aditya, do you have any other thoughts here?
Yeah, I think I have one more aspect that might be useful to think about. I think whenever you hear the term SQL, one of the first things that you learn about if you're teaching if you're taking a databases class is SQL is declarative, right? And on the other hand, Python is an imperative programming language. And I think some of the differences that Pandas and SQL have can be I think one way can be attributed back to this imperative versus declarative divide of people in the declarative mindset, you specify what you're looking for, what the end result should be without specifying the steps. And in the imperative way, you're specifying the steps that take you to get to the end result. Now, while this is a conceptually useful distinction, in practice, you could, underneath the hood, it could all be done the same way, right? You could still take something that is specified step by step and say, you know what, the right way to execute the sequence of steps is not in this way, but in this other way where I've reordered the steps, but it gives you the same result, right? So, and that's totally fine. But a mentality or a framework conceptually to think about it, it's sometimes easier to think declaratively for certain types of operations, sometimes easier to think imperatively for certain types of operations. And from a user ergonomic standpoint, this is a useful axis to compare against as well. So the imperative versus declarative divide, the user facing sort of ergonomics for both of these languages are also different.
Let's push on this for just a moment on this question of these five axes potentially. We mentioned that the personas are different typically between the two languages. Could you just really quickly, Aditya, maybe how do you see the personas of SQL versus Pandas? In what way? Who are these personas? Yeah, so I'm happy to talk about that. So I think traditionally the difference between the SQL user and the Pandas user has been the following, which is that the SQL user and the SQL users are traditionally business analysts or data engineers. And these two camps fall at different ends of the technical spectrum. So folks who are very, very technical or the least technical, right? And then on the Pandas side, it's the data scientist persona, right? It's basically folks who want to do machine learning,
or who want to do exploratory data analysis. Those are the folks who do Pandas. Now, these labels are a convenience, but they're not quite accurate. I think there are folks who would think of themselves as a data scientist, but they largely do data engineering. There are folks who think of themselves as data engineers, but what they're largely doing is data analysis and data science. So these labels are fluid, and I don't think there are any clear boundaries. And so I think it's convenient to refer to these terms, but I think at this point, they are so fluid that it's not very useful. But traditionally, that's the difference in persona. It's data analysts and data engineers, the SQL camp, data scientists and machine learning folks in the Pandas camp.
And then maybe Sesh will turn to you for this. So use cases and applications. I actually think going through these four is a helpful way to sort of set up a lot of our discussions. So use case and applications, typically, how do those differ? And this relates to the personas thing, but I think there's perhaps a little say beyond that.
Right. No, you are absolutely right. Typically SQL has been used for business applications, right? I mean, that's why it's a multi-billion-dollar industry. It's perhaps one of the biggest industries out there. And it's been used for, I would say, ad hoc querying a lot, which is, hey, I'm in a business meeting. I need to know what was my sales last week for blah, or very, very sort of point things. That's one extreme where a business analyst is, kind of just giving you basic business data. Let's call it meat and potatoes, right? So basic stuff. And then the other extreme is, like Aditya said, there are data engineers who are doing some complex processing, optimizing the heck out of, whatever they're writing. But these are large reports that are getting, these are not ad hoc queries. These are well thought out reports and analysis that are getting performed, and so that's the other extreme. So ad hoc queries, just simple queries, and deep reports, deep analytics is what I would call typical use cases of SQL. The typical use case of Pandas is more of exploratory analysis, building on your previous analysis and continuing to build, continuing to develop, and leading to perhaps very deep machine learning algorithms or deep learning algorithms, right? So you're kind of getting some data, pivoting it, scrubbing it, doing various things, but all in a very, I want to say, so I think the time frame difference to me between SQL and Pandas. In Pandas, there's one user sitting in front of it and probably in the order of minutes making changes, whereas the deeper queries for SQL is, first of all, it takes probably sometimes days to execute anyway, so because of the amount of data that's involved. But it's a bit more well thought out what you're doing.
Yeah, great, thank you. How about the ecosystem? Aditya, can you describe a little bit the different ecosystems that exist around the tools?
Yeah, again, I think there's like my answer would have probably been different 5 years ago, but now there's a lot of convergence, just like I see convergence in personas. So in the past, I would say, hey, SQL tools or relational databases, there's an ecosystem of BI tools that sit on top, right? So basically, your tools like the visualization tools like Tableau or Power BI, or even, so that's on the one end. There's also a whole bunch of relational databases powering user-facing applications, right? Like web applications, SaaS applications. All of these applications are powered by relational databases. So that's an ecosystem of stuff around it. As it pertains to the data work, so data analysis, data exploration, data analytics, I would say the more interesting pieces are the BI pieces, right? So it's basically Power BI and Tableau and other Looker and other visualization libraries. Pandas lives within Python, and Python has a rich ecosystem of open source libraries for data analysis, data visualization, and machine learning. So you have packages like PyTorch and scikit-learn and TensorFlow and all of these languages for machine learning. You also have NumPy for linear algebra type operations. And so all of this comes in a full-fledged programming language, Python. And so users typically mix and match these languages as they proceed over the course of their data analysis. And they also visualize along the way. So they use tools like Matplotlib or Seaborn or Altair or Vega along the way to visualize intermediate results. So that's the ecosystem. It's sort of like similar purposes, like BI is similar to visualization tools, open source visualization tools, but a little different. I would say there's not been as much machine learning tooling development in the SQL space as there has been in the Python and Pandas space, but at least on the visualization side, there is definitely a lot of overlap. One piece that I think is much more catered towards the non-technical folks is the BI tools. So BI tools and visualization tools like Tableau are catered towards folks who don't write any programming at all. And I don't know if there is an analog in the Pandas space. So if you think about tools like Excel and Tableau, they're really targeted at folks who can't write any programs. They may not even be aware of SQL, but underneath the hood, some of this work that they do on the front end gets translated to SQL.
Peter, if you don't mind, just one small addition, just teeing off what Aditya said, the point about the no-code, low-code tools, no-code pretty much, BI tools. And one part of, the reason why I'm doing this Intro to SQL course is to argue that a little bit of SQL knowledge is very useful even in this context. So, just to put it out there, yeah.
Thank you. That's great. Yeah. So we talked about personas, about use cases. We talked about ecosystem, and then you mentioned imperative declarative. So I think the last one is performance scalability. I actually think we have some other questions about performance scalability. So we can come back to that in a moment. So this is a little self-indulgent, but I think one of the goals of this meetup is like group catharsis. It's like every day you live a life and you code and you run into these issues, and you could talk about them with your data friends at work, but like probably your personal circle, it's like that doesn't really resonate or something. And I feel like here we've got a group of people who have some common experiences. So actually one thing I want to do, if it's all right, is I think one way to sort of expel, what's the sort of dramatic phrase, is like expel your demons, but like one way to like kind of let this out is to ask each of you to wear a partisan hat and to like ask a pointed question where you're supposed to basically rip on one of the languages or something. And I recognize both of you have a great respect for the utility of data frames and databases. You're both experts. So if you're quoted out of context, maybe this will hurt your careers, but we'll trust that won't happen. So this will be rapid fire. I'll give you a point of view to take, and then I want you to, within that point of view, share the thing. So let's start with Aditya. And have you wear the sort of pro Pandas hat. So this is Pandas Aditya. This is not just normal everyday Aditya here. Okay, so what is one really annoying task to do in SQL?
Transpose is really hard to do in SQL. I would say it's impossible to do in SQL. I challenge anyone in the attendees to come up with a way to do transpose in SQL and share it in the chat. But I'll leave it at that. So that's one really annoying thing to do in SQL. But in Pandas, it's really easy. df.t, capital T, transpose, done, right? Anyway, that's my one answer.
Yeah, totally. Okay, Sesh. So this is again not everyday Sesh you'd meet on the street. This is pro SQL Sesh. What's one really annoying task to do in Pandas?
I have to say I'm not a power user of Pandas, but I'll generalize this a little bit and to Python. And I think for me the most annoying thing, just coming from the world I come in, is the fact that I could make mistakes and it doesn't get caught. I can misquote variable names. I can mistype variable names, and I know a lot of these things are changing, but at least as of 4 years ago, when I first started programming in Python, that was a lot of grief for me.
Okay, that's great. Okay, Sesh, now we're going to have pro Pandas Sesh. Okay, everyone, this is pro Pandas Sesh. Why should an aspiring data scientist definitely start by learning Pandas instead of SQL?
I think just the pace and the environment that you have available to you as a data scientist, I mean, the speed with which you can develop stuff, the speed with which you can develop intuition, first of all, for the data that you have at hand, and the ease with which you can combine it, with other machine learning tools like scikit-learn or TensorFlow or PyTorch or whatever, right? I mean, I think it's just seamless. It flows beautifully, along with the visualization stuff, matplotlib or Simon, whatever it is, right? So I think it's just that package is beautiful. If I were a data scientist, I mean, which I that's my sort of hobby, if you will, and I just revel in using Pandas in this context. Yeah, that's what I would do. Yeah.
Okay, that's great. Aditya, this is pro SQL Aditya. What's one reason that definitely start with SQL, not Pandas?
One reason I would definitely start with SQL rather than Pandas is because SQL is, you can do a lot with a small number of keywords in SQL. So select from where, group by, you take those keywords and then you mix and match and then you rotate it around and around and then you get a whole bunch of stuff that you can do. So it gives you a lot. Whether it gives you what you want is another question. So sorry, I'm putting my pro Pandas hat back on, but I'll take it off immediately. It's really easy to learn if it's just a handful of keywords. So and which makes it really easy as a database professor to teach, right? So it's easy because it's like, hey, memorize these 7 keywords and you're good to go for a large number of queries that you may wish to issue.
Okay, that's great. Aditya, we'll stay with you for a second. So this is now pro Pandas Aditya, who made a little guest appearance a second ago. Okay, what's one task that in Pandas, when you do it, is like as easy as cutting through butter, like a walk in the park, like a breeze in summer?
So this is the one task that's popping into my head right now. But so a useful task in machine learning is converting data from categorical to numerical. So if you have a column that's categorical, let's say these are like product names or something, and you want to transform it into a numeric column where you take those product names and you create a new column corresponding to each of those product names. So you're basically doing what is known in machine learning as a one-hot encoding. That's really easy in Pandas. It's just this function called get dummies, and you're done, right? It's just like one step, and then and you're done. And this is true for a lot of machine learning like operations or operations that are useful as a precursor to machine learning. So feature engineering, feature selection, data cleaning, that sort of stuff is really easy to do in Pandas, much harder to do in SQL.
Yeah, that's great. And Sash, I'll turn this to you. So now you're pro SQL. What's one thing that's like flipping a light switch or drinking a cool glass of water?
I think just writing simple queries on large amounts of data. I mean, I have large amounts of data, but I can very quickly, I mean, I'm whatever, large enterprise, or I'm a product manager in a startup, and I have tons of user data maybe, and I really want to know, hey, where are my users coming from? Which geography is producing the maximum number of users? Which category has the maximum sales? Which combination of users and categories are producing the most value for the business. So it's this slicing and dicing of the data on large amounts of data that you can just open a SQL shell, and as Aditya eloquently said, write it in five sentences or 4 sentences. Select blah from blah, where this thing group by having. This is it. And you can, if you are an expert in SQL, this takes you like, you get up and you can do it in like less than 30 seconds. And that's the speed with which you can do this focused task, which I think, I mean, I'm not saying it can't be done in Pandas. I think Pandas, the biggest really problem is getting the data into the Pandas environment or ecosystem, so to speak.
Yeah, that's great. Okay, so last question in these, like forcing you to take a partisan position. So this will be, let's have it be pro databases, pro SQL sesh. What's one reason oh, actually, no, this is the reverse. this is pro Pandas session. What's one reason databases might not be around in 50 years, but data frames might be? So again, this is pro Pandas session.
Yeah, no, I honestly, I think we will, and the main reason is just evolution. I mean, evolution of technology in my mind. Data frames are a strictly superior data model to the relational data model in the sense that they have more richness, so to speak. And so to me, I think that we have to find a way to make that work with all the goodness that we have built for the relational data model transferred to this. So in some ways, I expect Ponder to be leading the way, but I really expect this to happen. Yeah.
And then Aditya, I'll turn it to you, and I'll say, SQL. So this is pro SQL, Aditya. SQL has already survived so much. Like NoSQL came in and SQL survived, and relational database survived. What's one reason that data frames might not be around in 50 years, but databases might be?
So I'm gonna joke for a second. If someone suddenly decided to blow up all of Stack Overflow, there's a good chance that data frames may not make it. I'm kidding a little bit, but it's like usually when you're trying to figure out how to issue a particular data-centric operation, you turn to the internet for help, right? In Pandas, you turn to the internet for help. How do I take a column and then split it into two columns, right? You type it into Google and then you get to a Stack Overflow page and then you find the right Pandas incantation and then you put it into your notebook and then you're good to go, right? So I think that is a pretty common mode of development for a lot of Pandas newbies, at least if they're getting started, figuring out what to say at each step using help from the community. If for whatever reason that community were to kind of disappear, that would be a huge loss for Pandas relative to SQL. At least for SQL, the set of keywords is small enough that it might be easier for people to remember, even if the community wasn't there to help them. So that's one thing to think about. But I mean, I do believe that I think there are folks who've been schooled on, there's now enough people who've been schooled on both Pandas and SQL that like, looking forward 20 years, 50 years, there's going to be a pool of people who are still Pandas aficionados, or even if it's not Pandas, they are data frame aficionados. And then there are SQL aficionados. And the question is really a question of how are we going to, how these technologies going to evolve and converge or diverge over time? Are they going to coexist? Are they going to meld into one thing? And that's an open question. We don't know. But I see that there are certain movements to make that kind of bridging across these communities happen in a more fluid way. So certainly, so the focus of this meetup, right? Scalable Pandas. The approach that we've taken towards scalable Pandas for Modin, right? This open source tool that we've been developing for scalable Pandas is drawing on ideas from the database community, right? So if the database community hadn't done all of their amazing work in query optimization, there's no way we would have been able to make as rapid progress on making Pandas scalable without their help, right? Think about the timeline, right? So Pandas becoming scalable, at least the efforts towards making that happen have all happened in the last decade, half decade or so, while SQL has had, relational databases have had 5 decades to perfect query optimization, right? So you don't want to lose all of that magic. You don't want to lose all of the good stuff that community has developed. You want to borrow it as much as possible. But then you expose any number of user interfaces, right? So the eventual goal here for me would be, can we get to a point where there are a plethora of interfaces that we might have, not just Pandas and SQL, but even other interfaces, and all of which get transpiled down into a very flexible but powerful and optimized backend engine that can execute whatever the user intended in the best possible way. Right? So that would be the holy grail here. Sorry, I went off on a tangent, but yeah, so hopefully give a little bit of a sense of where I want the world to go.
That's great. Okay, so just for people's awareness, so at the 45 mark, we'll turn to audience Q&A, and you're welcome if you need to leave, you can leave at that point. We sort of thought of this as a 45-minute event, but we'll keep going with audience Q&A for a little while. In the remaining time, I have sort of two questions I would like to dig into. One of those is when I was, anyway, data pipelines, my experience as a data scientist is like data pipelines, they're written in SQL, and you have like things get changed and changed and changed and changed, and finally you have some resulting table, and data scientists might pull that into a data frame and manipulate. What is there a version of the world in which those data pipelines are written like in Pandas? And if so, how do we get there? Like, why are we not there now? And either Seshal or Aditya, if either of you want to take this question, like, is there a world in which data engineers work in Pandas every day? Yep.
I can go first and then Aditya. Yeah. I don't see why not. I mean, it's not there today. Simply for the reason that we don't have scalable pandas yet. I mean, I think it's as simple as that. There is value to, potentially using something like pandas because it's got a richer set of operators, if you will, to transform data. Yeah, so I think it's a matter of just not, being able to handle petabytes of data on multiple machines and large clusters, things of that sort.
Great. Yeah, Aditya, do you want to add?
Yeah, I completely agree. I feel like the modality that you mentioned of saying, hey, I'm going to do all the pre-processing in SQL and then switch to Pandas mode, it's primarily because of the scale, right? If we were able to, like going back to my vision, what you would want is for data scientists, analysts, who cares what the persona is, but like the person who's doing the analysis to determine for each task whether it is better done in SQL or in Pandas, right? So for me, for example, I'm very comfortable with doing joins in SQL, not as comfortable doing joins in Pandas. I'm much more comfortable doing columnar style operations, feature engineering style operations in Pandas. So why can't I simply mix and match one operation in Pandas, one operation in SQL? I shouldn't have to care about how it gets executed. It should just get executed in the best way possible. Right now, there is this artificial divide where if it is like petabyte scale data sets, then I have to do SQL. And then if it is like megabyte scale data sets, I can do it in Pandas. And there's this gray zone in between where I can either use some workarounds or I can use tools like Modin to move up the amount of data that I can operate on in Pandas, or equivalently try to do it in SQL if it is easy to do in SQL. But it's kind of like there's a gray zone in the middle where I don't quite know which tool to use. But that's why you have this phenomena of starting in SQL and then moving to Pandas, right? It shouldn't be that way in my mind. The ideal outcome should be you pick the right language for the type of operation that you're doing at each step.
Yeah, and in the chat, this is from a few minutes ago, but Jason Dexter was talking about when he first touched SQL, he was like, how do I do pivot unpivot? And I had the same experience where I came into SQL through Pandas and R, and I was like, it took me so long to realize I cannot think of a database as a matrix, and you can't do matrix operations and calculate standard errors that are complex and whatever. You can't do that in the SQL world. That took a while for me to realize. I think so. The last question that I was hoping to ask, and then we'll turn to audience Q&A, is this is some prognostication. So some I think this is a standard thing where panelists get forced by the host to make guesses about the future because everyone wants to hear people's guesses. But how do you think there's a relationship between SQL and Pandas, or more broadly between databases and data frames, will be different in 10 years? And I don't know, we could start maybe with you, Sesh, and then
Sure.
We'll turn to Aditya.
Sure. I think the general direction in which things are going, right, is essentially we need better and better integration across all of the tools that are out there at scale and with performance, right? So that's basically, so if you think about it, on the one hand, scale, performance, limited querying ability, comes with SQL relational databases. Much better integration with other data learning or data science, libraries comes with Pandas, but you don't get the scale and performance. I really think this boundary should be blurred. And honestly, for me, SQL or Pandas, they are just languages that are trying to express some computation that you have in mind on an underlying data model. And finally, the richer the data model, obviously, you have advanced the world. And I'm not so obsessed about, honestly, the syntax of language 1 or language 2, but richer data model, richer integration with deeper, data science stuff at scale, at performance. This is where I would like to see the world in 10 years.
And do you think SQL is going to counterpunch? It feels like a lot of progress is likely in my head to be made by Pandas and data frames. Do you think SQL is going to be like, oh, we've got to figure out how to do blank and blank operation that data frames can do because they're coming for us?
And I'll answer that, and then we'll get Aditya's viewpoint. SQL is not one company or one entity, right? SQL, and it's not. So will it counterpunch in the sense? I think if there is business value, it'll counterpunch, right? So if there is perceived loss of business, and it's already happening. Think of Databricks, right? Databricks is a hybrid company for me. Spark and something data lakehouse, if you will. Spark is a data frame at the end of the day. And SQL already has regression built in. So you can, today there are enough guys who try to provide much more scientific computations within SQL. So they're trying to do that. Now, having said all of that, I think Python and Python more in general than Pandas, the Python environment is so rich and there is so much out there that the language construction has developed by design, whether it's lazy evaluation, whether it's composability, whether it's functional stuff, that I think to sort of retrofit all of that into SQL. I think Aditya mentioned the declarative versus imperative. Actually, there's another fundamental difference between SQL and Python, which is SQL is not meant to be Turing complete, which means it's not meant to really do any computation in the world. And Python by design is meant to do any computation in the world. So my honest answer is that we will, this business of trying to make an imperative language work of databases has been tried in the past. They are called object-oriented databases, object relational databases. This impedance mismatch, if you will, has been addressed in the past, but I think Python and Pandas are coming at it the best way that I have seen so far. So I don't know that SQL will be able to counterpunch that part if Python and Pandas can cross the performance chasm.
Yeah, Aditya.
Yeah, so I agree with Sesh in that there are relational database companies, or at least companies that are offering SQL, are trying to get into the business of data science and machine learning to the extent possible, right? Be it through user-defined functions as part of SQL, or through machine learning primitives, right? So BigQuery, for example, offers machine learning primitives, right? So you can build models all embedded within SQL, and likewise you can embed Python functions in sort of SQL-like languages, like in Snowflake, right? So you have their Snowpark initiative, which allows you to embed some Python fragments. But going back to the imperative versus declarative divide, there's kind of as Sesh mentioned, there are kind of guardrails for SQL. There's only certain things that you can do, and for those things, it's very convenient to do and easy to do operations that obey the SQL style of issuing queries. If you deviate from that, it becomes very inconvenient, right? So in my experience, most attempts to include machine learning as part of SQL have not been very satisfactory, as they have kind of artificially limited power. And often data scientists are like, let me add it, right? Don't add these guardrails. Let me just get at the data, do what I want to do to the data. And that's the kind of flexibility that you get with Pandas. So it'll be interesting to see how these things shake out. At least on the Pandas side, one thing that I'm seeing as a new opportunity and something that I see us working towards as a community is enabling Pandas on data infrastructure broadly defined, right? So being able to leverage relational databases, being able to leverage big data systems to the extent possible and not reinventing the wheel there whenever it's convenient, right? So for example, if you're doing a relational like operation in Pandas, why don't you simply use a backend relational database to execute it, right? If you're doing something that looks like a join, if you're doing something that looks like a filter, if you're doing something that looks like a projection, why don't you use a backend relational database to execute it? So I predict that in 5 to 10 years time, we'll be in a position where we are more fully leveraging mature backend execution engines while still continuing to support the Pandas API, right? And so empowering folks who are using Pandas to operate on much larger scales of data than they're able to do right now.
Sounds great to me. I hope that this pans out that way. Okay, this has been so great. We'll for just a couple minutes, we'll turn to audience Q&A and then we'll pull this to a close. If you want to ask a question, just type it in the chat, or I believe there's a Q&A option as well. So we have one question already, which was from much earlier, and the question was from Garish Hari. It was, isn't there a market opportunity for enabling a no-code-like setup or offering for SQL programmers using the visualization support libraries that Pandas come up with? So it's a question about, yeah. Do either of you want to?
I can try to answer that. So I think there is already attempts to do things like this. So it's not quite the visualization libraries that Pandas has, I guess, integrations with, like be it Seaborn or Matplotlib, but you can already you have no-code tools, visualization tools like Tableau. Tableau is extremely popular. Power BI is another extremely popular no-code visualization tool that sits on top of relational databases, where you don't need to write any code. You can basically click a few buttons and generate visualization. So these are things that are already supported. For folks who are already in the no-code mindset, I don't see a benefit that comes from the additional power that you have with Matplotlib or Seaborn, right? So the ability to tweak various parameters, tweak the visualization to the extent that you want. I don't know if they would be able to appreciate that power and make use of it in a low-code interface. But so I would say in that case, pre-existing visualization tools like Looker and Tableau and Power BI already suffice. They give you some of this no-code capability, and that's actually already pretty good.
Great, thank you for that. Are there any other questions before we close? We have time for perhaps another question. I think this has been very meaty, and we're at 53 minutes, so I think this is a good opportunity. I wanted to thank Sesh and Aditya, and thank our partners at CoRise for co-hosting this with us. I learned a lot. This is very fun for me. And thank you so much for everyone for attending. We have our next meetup in 3 weeks on July 28th, and we'll send more information out via Twitter, but also through our mailing list. And again, remember that Sesh's Intro to SQL course starts later this month, so you can go to corise.com, learn more about that. All right, thank you so much, everyone, for coming.
Awesome. Thanks, folks.
Bye.